Alright, hello everybody. For today's lesson, we're going to be covering the precision instrument approach. With a precision approach, it's mainly going to be an ILS. Localizers are considered non-precision approaches because they don't have that vertical guidance and go down to a minimum descent altitude. With an ILS, you will go down to a decision altitude instead. There are some approaches that do have vertical and lateral guidance that go down to a DA but aren't considered a precision approach because they don't have the ground navigational aid that is required to make it precision. So, some main information that covers, so let's go over the name. For this, ILS localizer runway 30 right. If there are multiple, they will be alphabetical order backwards, so Zulu down to Yankee. With that, the higher, I guess you could say, the closer to the Z that letter is, the lower the minimum is going to be. Which is important because if you're flying in terrible weather, you want those lower minimums to be able to reach that airport and have the best odds of landing. Alright, so let's start from the top. So this is the ILS localizer, 30 right, for Meadows Field. Our localizer DME is going to be 111.9, channel 56. So with our G1000s, as we put in that approach and plug it in through procedure and flight plan, it's going to automatically tune into that localizer, but if we don't have that, we can always click in that localizer. Our final approach course is going to be 301, which means on the final approach fix, we're going to be holding a heading of 301, a course of 301 to that airport. The runway landing distance is going to be 7,429. Touchdown zone elevation is going to be 493 with an airport elevation of 510. Those can differ because a touchdown zone elevation, I believe, notes the first third of the runway, whereas the airport elevation is the entire runway. So if there's an upslope, you're going to have a lower touchdown zone elevation and a higher airport elevation. If it's backwards and there is a downslope, you're going to have a high touchdown zone elevation but a low airport elevation. Those matter because for landing larger aircraft, we want to be able to have the best chances of landing, and on a smaller runway that has a downslope, you're not going to be able to get as much traction when you're braking. You're going down with gravity, so you're not slowing down as you would on an upslope, and that could change a landing from a go to a no-go. All right. Now going over to the next part. There we go. A great tool for this is the Digital Terminal Procedure Supplemental. It's going to tell you everything you should know and you'll need to know for approaches. So, these two triangles right here are going to be airport is published in takeoff minimums, obstacle departure procedures, and diverse vector area tabulation. And for the A, alternative minimums are non-standard, which means minimums are going to be different from what's expected. Now, circling northeast of runway 12 left, 30 right, DME is required. Circling not applicable, not available. We can't circle northeast of runway 12 left, 30 right. DME is required for this approach. VDP NA, or visual descent path, not available with Porterville altimeter setting. When local altimeter setting is not received, use Porterville altimeter setting. Increase the DA to 790 and all visibilities to RVR 2200. Increase all MDA 100 feet and visibility Cat C and D to RVR 6000. For an in-op ALS approach landing system, increase localizer runway 30 right, category A and B visibility to RVR 5000. For in-op ALS using Porterville altimeter setting, increase ILS 30 right, all cats visibility to 5,000. So these are all just different remarks, different notes. So if we don't get the weather here, we have to get the weather from Porterville. If we get the weather from there, what changes and what should we adjust for given the fact that we don't have the perfect altimeter setting for this airport? This uses Mulser. Let me see if I can find this one here. But this is going to be Digital Terminal Procedure Supplemental along with the AIM. The AIM is going to give you a lot of great references regarding this. If I can find it. Here we go. So, digital terminal procedures on ForeFlight. If you go to page 18, it's going to have the different approach lighting systems and what they all will look like. Great tool to have as we're coming into an airport, especially if it's an unfamiliar airport. Now, next is going to be our missed approach. Climb to 1000, climbing right turn, 3000, shafter, VORTAC, radial 145, direct, shafter, VOR, and hold. Continue climbing to hold 3000. So, as we approach our DA, if we reach our DA altitude of 698, and we don't have the runway, we can't make the landing, we'll go ahead and start with our missed approach. We can see it marked in the map here. We're going to be climbing to 1000, then right turn, 3000, shafter, VOR, radial 145, direct shafter, and then continue that hold. Now, alternative missed approach fix is going to be if we don't have that shafter VORTAC. We're going to be able to shoot an alternative missed approach and hold on IVECU, both on the Thule and Avenel radial and channels, to be able to triangulate that exact point. So we know if Avenel, if we're on radial 072, and if we're on Thule 172, and they're both lined up here, that we're on that track for IVECU. And we know that with Thule, if we have a DME of 15, we're also on that spot. So, going back here, our ATIS 118.6, the weather that we'll need, Bakersfield approach control. That's going to be 118.8, 118.9. Odds are we'll be talking to 126.45 if we're in the local area. Tower is going to be 118.1. Same with the CTAF if tower is down. Our ground is going to be 121.7, and Unicom is going to be 122.95. As we're going down, we'll go ahead and get a map view of the airport. So again, we have our missed approach, we have shafter telling us all the channels, all the frequencies, all the information we'll need to know. Different altitudes along with all the mountainous terrain and any obstructions that will block us as we're coming into our approach. Sorry. Along with this, we have a minimum sector altitude. Shafter, VOR, 25 nautical miles. So from Shafter, 25 nautical miles around this is going to be safe altitudes. We know that on this side, it's going to be 3,700, and on this side, it's going to be 8,800 because the mountain's there. So if for whatever reason we lose our approach, lose this, and we need a guaranteed safe altitude, and we're not on a track or a fix, we know that 3,700 we're safe on this side of Shafter VOR. Get some more information here, multiple fixes, the DME points, so the distance from the ILS to that point and exactly where it is. We know our final approach fix as well is going to be JUPEX, which is also initial approach fix. Now, if we start from, let's say, Gorman, if we start from Amont, these mark no PT, no procedure turn. If we start on JUPEX, we have to complete a hold in order to line ourselves up and get ready for that approach. Coming in from Gorman, coming in from Amont, if you're getting vectors as well, you won't need to do that procedure turn, which is what these no PT are. Along with this, you get your altitude, so we know that if we're joining from Amont on this track, we need to be 4,500. The course is going to be 301, distance 7.4, etc. For that leg, sorry. This is the DME, this is going to be the legs distance, I believe. Now, procedure not available for arrivals from Amont on Victor 459 southeast bound, and procedure not available for arrivals on Gorman, VORTAC, Victor 137 southeast bound. These are just telling us different ways that we cannot join the approach if we're on those Victor Airways. Going down, again, we get the elevation, touchdown zone, a lot of information about the airport. Again, see that slight slope of 0.3 degrees up. We have different markings. Again, the approach lighting, where the tower is, the length of our runways. Yeah, more information as well. And all this is going to be listed on the Digital Terminal Procedures Supplemental. It's a great resource. There is so much to know about instrument flight, so that's always a great tool to have. And again, the AIM as well will tell you a lot that you'll need to know regarding each of the systems. Because again, we have VOR approaches, we have ILS approaches, localizer approaches, all those different types of approaches. And that'll tell you all the information you'll need. Some more information on that. This is our plan view. So what this is going to show us is how it's looking from the side. We have our missed approach right here, telling us just a quick hand reference of what we're doing, where we're going. Use DME when on the localizer course. JUPEX, our final approach fix, is marked by this Maltese cross, and this lightning bolt is telling us where the glide slope intercept is. 9 times out of 10, they're going to be together. Sometimes they won't be. 1 minute holding pattern, and again, that's for different approaches as well. So it's telling us on our hold, our 301 inbound, 121 outbound at 2,500. We know once we intercept this, we can go ahead and start that descent on the glide slope for the runway. And then we have a visual descent point as well. From this point, we should be able to see the runway and continue down. If we don't, we continue down to our DA. After that, we go missed. And we have the different categories. These are based off your airspeed. I believe it's 1.3 times one of the V speeds. Sorry. Let me see if I can find it real quick. Let's see. Come on. Apologies, I cannot for the life of me find it. But I believe it's based off one of the speeds, and essentially the higher your speed is, the different your minima is, because you have different descent rates, different approach rates, and speeds. So we know for the ILS, we're going to have a DA of 698. And as we're coming down, we're holding that to our minimum. Once we hit that, we go missed. More information about the distances, and then if we shoot the localizer and the circling approach. So precision approaches, really strong. Can be complicated depending on which ones you shoot. The one we shoot here in Bakersfield, fairly simple, nice, easy training one. But there's, again, a lot of information. All these different remarks to make about it, where you're coming from, whether or not you're getting vectors, and flying an approach is a lot different from looking at it in paper. But as you're flying this, you need to be able to brief it real fast, know what you have to know, information, different where you're coming from, where you're approaching. All great information. So, yeah, that's precision approaches.